Hello everyone. So today I wanna do an article critique. The title of the article is Design and Effectiveness of Modeling-Based Mathematics in a Summer Break Program. Here's the background information. Student success in their first semester college mathematics course is a key factor in their success in engineering. Therefore, many summer break programs for underrepresented students focus on their preparation in mathematics. However, research on the design and efficacy of such programs is limited, and that's why this research is conducted. Our research examines the design and effectiveness of a modeling-based approach to mathematics for entering freshman engineering students. Here are two research questions. The first one is that, does a modeling-based mathematics course in a bridge program positively affect student performance in their first semester college math course? The second one is that, to what extent does a sequence of modeling tests support the development of students' concepts of average rates of the change? Design. This study is a quasi-experimental study, and it compares two cohorts of bridge program students to examine the effectiveness of the modeling-based math course on first semester math course grades. Second, the pre and post tests. These two tests were administered to measure the improvement in students' understanding of average rate of change. Here's the sample information. In the table left, it shows some basic information for the students in both two cohorts. And the key point is that the participants in 2007 to 2009 cohorts took traditional college algebra and pre-calculus courses. By contrast, the participants in 2010 to 2012 cohorts took modeling-based courses. Also, the difference in the basic level of mathematics also may have some influence for the final result. So the SAT scores need also be considered as a covariate in the later research. And here's the comparisons of SAT scores of non-participants and participants. We can say all of the p-values is less than 0.5, which means there exists a significant difference between the two groups. And here is the procedure. For the first research question, there are two comparisons conducted. The first one is between the participants in 2010 to 2012 cohorts and 2007 to 2009 cohort. The second comparison is between the participants and the non-participants in 2010 to 2012 cohorts. And both comparisons test the effects of SAT scores as the covariate. For the second research question, the comparison of the pre-test and post-test results were conducted for the rate of change concept inventory. Here's the results for the first research question. And now let's see the first comparison result. In the table, we see that the p-values for both pre-calculus and calculus 1 are less than 0.05, which means the student who took the modeling-based course performed significantly better than the students taking the traditional courses. Also, an analysis of covariance is conducted to test the effect of bridge program participation by cohorts with SAT scores as a covariate. In the table, we saw that the participants by cohorts have a significant effect on the first year mathematics scores because the p-value is less than 0.0 is 0.001. Yeah. Now let's see the second comparison results. In the table, we notice that for pre-calculus, the p-value is larger than 0.05, which means there's no significant difference between the pre-calculus grades of the non-participants and participants. And this indicates that the modeling-based courses helps participants close the gap with the non-participants in the pre-calculus grade. However, the p-values of calculus 1 is less than 0.05, which means there still exists a significant difference between the two groups. Also, the COA test is conducted to test the effect of the program participation on calculus 1 grades with SAT scores as a covariate. Here, we can say that there's no difference in calculus 1 by the participation of the modeling-based courses, but rather the difference in the calculus 1 grades can be explained by the difference in SAT scores with the p-values less than 0.001. Okay, now let's see the results for the second research questions. Here, the comparisons of the pre and post-test results are conducted for the students in the 2010 to 2012 cohort. And we can say for each year, the p-values is less than 0.001, which means the modeling-based courses helps the students develop their understanding of the mathematical concepts. Here's the conclusion. The participants in the 2010 to 2012 cohorts who took the modeling-based mathematical course also performed their peers in the 2007 to 2009 cohorts in both pre-calculus and calculus 1. Besides, the substantial improvement in the first math course grades closed the previous gap between the participating and non-participating students in 2010 to 2012 cohorts. Thus, the modeling-based course effectively prepared the students for success in their first semester mathematics course. Second, each year of the course, significant gains were found on the post-test in student understanding of the concept of average rate of change. This gain indicates that the course targeted learning outcomes were achieved. Here's the strengths I summarized for this research. First, rather than simply comparing student performance in their first semester college math course, the study considers that student SAT scores as a covariate, which makes the analysis results more reliable. Because if we only focus on the scores of the mathematics, there may some other variables influence the final results. And the second one is that for the first research question, researchers not only compare the participants and non-participants, but also compare the participants who receive the traditional courses and the modeling-based courses. Therefore, we are able to know that in addition to improving student achievement, the modeling-based courses are more effective than traditional courses of the past. Now let's talk about the limitation in this research. First, there are other variables that may influence student success in their first year math course, such as self-efficacy in mathematics, peer interactions and study groups, or general academic study skills, and so on. Second, as I mentioned before, the relatively small number of the participants in the bridge program leads the research to be cautious in interpreting the results of the study. The last one is in the use of mathematical course grades as indicators of study success. As we know, for different teachers, their course design or the grade scales may be different in the same course, and this may also cause the final result different. And here's the inference for my article. And that's all. Thank you.